Hello fellow MEC 104 students. So today I'll be doing a real science experiment that demonstrates Newton's first law of motion, which describes that an object at motion would like to remain in motion and an object at rest would remain at rest. So for today's experiment, we'll be using these following items. We'll be using a Hershey's Kissie, which weighs in at about 0.2 ounces. We'll be using a jar of petroleum jelly, which the jar says that it's 7.5 ounces, but it's about a third used, so we're going to go with 5 ounces. A bottle of pink lotion, which weighs in at 16.9 ounces, but once again, it is slightly used, so we're going to say 16 ounces. And lastly, this rock. And this rock, I would say, I don't know exactly how much it weighs, but it definitely feels about like 4 times as heavy as this, so this is probably about 65 ounces. So for today's experiment, we'll be using the set table with the tablecloth method. I at first was thinking, we could do the experiment by showing, hey, look, this is at rest. I apply a force, now it's in motion. Woohoo! But clearly, I thought that we should take it a step further. So what we'll be using are sheets of paper, and we will put these 4 different objects on the paper to prove that regardless of their mass, they will still not move when the paper is removed from under the object. For today's experiment, we will be ignoring friction, just like how, say, if you're measuring a projectile or something, we usually ignore air resistance. What I noticed is that when doing these, it works best when the 2 objects are frictionless, so that way they don't act on each other. But since we do not have those conditions, I did my best to recreate those conditions. So we will be putting these objects on this plate, so that way the surface will remain smooth, especially for the rock, considering that it's not flat at all. So let's start testing. So for each object, I will place the plate on the upper half of the paper, so that way the object itself should sit between about the front 2 prong holes, which are about there. So first, let's test the Hershey's Kissie. In 3, 2, 1. So as you can see, the plate literally barely moved. But once again, we're ignoring friction, and if friction wasn't a factor, the plate wouldn't have moved at all. And once again, this Hershey's Kissie weighs in at about 0.2 ounces. The next one that we are going to try is the next heaviest item, which would be the petroleum jelly. Once again, this weighs in at about 5 ounces. So same thing. 3, 2, 1. Once again, the point of this experiment is to prove the force it's acting upon is the paper. So the paper is getting a force applied to it. So the paper should move. This is not getting a force applied to it, so it should not move at all. So once again, because of friction, it does a little bit, friction, human error, but once again, that is why we are ignoring that. So the next heaviest item would be the lotion, which once again weighs in at about 16 ounces. 3, 2, 1. Same thing. Didn't move at all. And lastly, because this one, and honestly, with the first 3, the friction wasn't that big of a problem. It really came in with this, because for one, as stated before, it's not flat at all. And then also, because of it being so rigid, it would rip the paper a lot. So that's when I came up with this idea to use the plate. But clearly, if I'm going to use a plate for one experiment, or for one item, I have to use it for all. So lastly, to test out the rock, and once again, I said it feels about 4 times as heavy as this, so I would assume that this rock is probably around 65 ounces. 3, 2, 1. Same result. literally didn't move. So there you have it, folks. Regardless of mass, Newton's first law of motion does still remain to be true. These four objects were not acted upon at all, and that's why they remained at rest, and it was the paper that was acted upon. And as stated before, when I pulled it, these didn't move because the force was on the paper moved. These were not acted upon by a force, so they remained stationary. Thank you.